Hello, welcome to part 2 of this video. So on this part 2, I'll be showing you how to model a Raft foundation. So we are using the software Protastructure. So by the end of this part 2 training, or the level of this part 2, you'll be able to model a Raft foundation. So right now, before I begin to model, I like to change the color of my building element or my structural element. As you can see, this color came as a default color with the software, and I don't like using it, so I just like to use my own custom color. So right now, I'll just go and change the color first before I begin to model. So I think this is just like a bonus for you, so that you can be able to know also how to change or customize your own structural element color. So you can see the icon which I just clicked just now. So I will allow it to load, and then once the labels appear, I will just change the colors for my element, like for slab, for beams, and for columns, and for partition walls. Okay, so right now I want to use my column color or my column hash color to be something of this nature. Let me just go here and then mix my color the way I want. Can go to this place. Here it's okay. Now can make this like this. Increase this a bit. Yeah, I'll go back a bit and then say okay. And I will come here on the beam. I have a beam here on this structure. I'll come here and then I want to choose my beam to be green this way, and then I'll click on OK, and I'll come to my partition, to my slab. I want my slab to be this dark blue here, okay, this color, and I'll choose that, and then I'll come to my partition walls, and I'll click on partition walls. I want to use gray, yes, and I'll say OK, and I'll tend to increase this opacity so that the walls will not be that transparent, and I'll come here and keep this here. Okay, that's fine. And I'll come now and say okay. So with this now, you see that all the colors of our members will change automatically. Okay, I think let me go and change the column. I don't like the column I'm seeing, the color for the column I'm seeing, or if everything looks okay, but for the columns I can choose to change it. I don't want to have that color for my column. And then for my slab also, I'll also reduce. Okay, for my column, I can go and choose this. Okay, this looks a bit okay for me for column. Let me choose this. Okay, that's fine. Or this, yeah. Then that's fine a bit. Then go say okay, and then come down now and change for my slab. Change for my slab, and I'll go and choose a lighter one, and I'll say okay, and I'll say okay. Let me see. Okay, this a bit okay. So right now you can now see that we have changed the color of our member. I can do that, but basically this does not include or affect the design process for your building, but this is just to get a good look of your members. Okay, so right now we will now begin fully on the design and also the modeling of this Raft foundation. So basically, before you must begin your foundation design or any kind of foundation design, you must have completed the design of the superstructure. So I repeat again, if you want to know how to design or to model this structure starting from the CAD file to this very stage, I would say that you can go and get the course on a 5-story building design on our website, ekidel.com, and then you can watch that. And also we have also attached the CAD file to the zipped video file, which you're going to get after you have made payment for this course. So that will look easy for you because you have the CAD file, and then you can be able to practice to how to design for this. Okay, so right now, before you must begin your foundation design, like I said again, you must have completed the superstructure design. Okay, and then we will now begin now for the foundation modeling for the Raft foundation. So right now, I'll go to my plan view on story 0. Okay, so how to navigate to your plan view on story 0? If maybe you are not seeing this, let me just assume that I'm on story 1 now. To now go to your story 0, you have to go to this place here. Make your story 0 active by double clicking on that. Now, once you double click on that, you will see only your columns. To tell you that that level you are is story 0, when you come to story 0, you will only see just the column points. That is the only thing you're going to see. Okay, so right now, and also if you check, you can see that each of the column points are carrying load. The G load, Q load, and then the combination load. How do you get this load activated for you? Although we are not going to use this load for anything, but just to show you guys how to get the load on each of the column. As you can see, each of the column has different load, as this is 810.7 kilonewton, and this is 807.6, and this is 958. So each of the columns have different load because they are carrying different loads. So how do you get this load activated or being shown here? Just by going to this place here, this icon here. Meanwhile, I'm using 2018 Protastructure version. Okay, so right now you're gonna now go to this place here that says column plan display. Click on this place here, and then you will see this place that says loading. First of all, check on your axial load and check button, and then come here and then say come to this place and check the load that you want to have. So you have to check here. You have to check the G load, the Q load, and then you have to check this combination that says G plus Q plus W plus N arrow bracket. Now, the reason for this W is because I applied a wind load for this. That is why I said you have to go and get the part 1 of this course video, which is the superstructure, and then watch that. Okay, so right now, once you say okay, and then say once you're done choosing all the load that you want to display, and then you say okay, and then final okay, you will just see your loads appeared here for you. All the loads that you have chosen for it to appear, you will see them here. Okay, so right now, to begin to model our Raft foundation, since I said we are using a beam Raft foundation, so we will have to now go. Meanwhile, this load, either it is showing on your own or not, it does not affect what we are doing for today. But you will need this load to display on each of the column if you're doing a pi foundation. That is where you're going to use these loads a lot. But for this Raft foundation, we are not going to use that. Okay, but that's just to show you how to display your load on each of the columns. Okay, so right now for a Raft foundation, to begin the modeling now, since I said we are using a beam Raft foundation, so a beam Raft foundation consists of a beam and then a slab. So right now, the first thing we will start with is to now begin to insert our beams. And to do that, I'll have to go to my beam here. To do that now, I'll go to my concrete member and then go to concrete beam. By clicking on that right now, the dialog box will appear, which is beam properties. And then I'll have to set my beam width and then my beam height. Okay, so right now, this is a 5-story building. So I want to choose my beam width. You can make your beam width to be the size of your block wall thickness, or you can choose 250. Now, the size of my block wall thickness for this building is 250. So I can choose to use 250, or I choose to use a higher one. So let me just say I want to use 300. Okay, for my width of the beam for the Raft foundation. And then for the depth now, the depth basically starts from 1 meter. So whenever you are designing for a Raft foundation, the first thing you have to consider for the depth is to start from 1 meter. If it is below 1 meter, that means you are going into a wide strip foundation. So, but from 1 meter, that's why we start our depth of beam for Raft foundations. Okay, so right now, Since this is a 5-story building, I will not consider using a 1 meter depth of beam. So I will start from using a depth of beam of 1,700 as my depth of beam. I would have loved to use 1.5, but I don't want to use 1.5 because I don't want to spend time, because most of the beam might fail. So I don't want to spend time after performing the design and it is being noted that most of the beams are failing, which I'll still go ahead and gonna increase. So I want to start my assumption for depth at 1.7. Like I said again, being the depth of your beam depend on the number of your story or the weight of your story. That's what I said in the part 1. And a raft beam depth can go up to 3 meters, can go up to 4 meters, depending on the weight of the structure. So right now, I want to start my own with 1.7, and I said again that the minimum is 1 meter. So right now, I'll go here and then uncheck this. You must not fix it or hinge it. So make sure there is no hinge applied to the beam. So I've put my width of beam, and then I have also keyed in my my depth of beam. So right now I'll just begin to insert my my beams starting from this point now, and I'll begin to insert just now. So I'll insert from here to this column. Now I'll do it now from column to column. So I'll begin to insert that now. Now if you look at now, you will see that because I use 250 as my width of wall, and then you can see that it is flushing here, but this column was having an eccentricity which was going inward. So I'll just continue on that. This doesn't bother basically for your foundation. So the raft beam can be bigger than the column in width. It doesn't matter, but the whole idea is that let the beam property should be able to carry the weight of the structure. That is the only thing. Okay, so right now I'm not bothered about this, so I'll continue again and then keep this here, and continue again and then keep this here. There was a reason why we have to push the columns inward. That is why if you watch the 5-story building design course video, you will know why we did this. Okay, so right now I'll continue again to keep this here. So the whole idea is to connect all your columns with a ground beam, with this raft beam or a ground beam, and then I'll continue with that, and then do the same thing here and keep this here, and then I'll keep this here also. So keep this here also, and then click here also. Now you can make it very fast by you clicking all the way down. Since you have columns all the way down here, I can choose to come here and then click here, and automatically it will divide itself. The beams will divide itself in at the column points. Okay, so that you don't have to be clicking each and every column, which will take longer time, because the whole idea in design is to the whole idea for the reason of software is to facilitate the time duration you are meant to spend on your raft foundation, or sorry, on your design. Okay, so right now I want to place this beam is going this way. If you check on our plan, is going this way. Like if you check on the plan here, which is the story 1, you will see that this beam is going to go in to this place. As you can see, let me just show you that. You will see that. Okay, yeah, this beam is going to this place. So right, that's why. Now before I must draw this beam, because this beam coming here is not anchoring itself on a column. So basically it is not acting as a secondary beam, while the beam here, which is carrying it, is not acting as a primary beam. So before you must insert a secondary beam, you must first of all insert a primary beam. So right now I'll click on this, right click, and then take back the beam property, and then go now to first of all insert the primary beam first, and then continue here. Then I can now go and escape, just one escape, and then click on this and then insert the secondary beam now. So what have we learned today? For this, before you must insert a secondary beam, you must first of all insert a primary beam. So I'll go now again and then click on escape, and then continue again. I'll now click on this place now, and then go all the way down to where this column is, and then click here. Automatically, the software will divide the beam on each of the column points and then give me different spans of beams. Okay, so right now again, I'll go again and then click here, and keep this here. And then I'll still go again now, and then click on this. Now, if I want to flush this beam now with the column, let me show you now, because you can see that it is now the column and beam is not flushing at the same plane. So to do this now, I'll have to apply the beam eccentricity. So I can come here right now, and then I'll first of all say escape first. Click on this escape button here, and then I'll check the distance between these two, between this edge of the beam and the column. So I'll come here just now and then click on measure. I'll just, first of all, I came here and then right click on this place, and I'll say measure, and I'll measure from this point now to this very point here, which is giving me x equals to 95, as you can see that. But let me just do it again. Right click, measure, and then from this point now to this point, if you look at it very well, this is giving me 95, yes. So I'll come here just now, click on this beam, right click, and then say properties, and I'll come to the eccentricity right now. Since the beam is 300 minus 95, that gives me 205. Okay. So I'll come here just now, and I'll say first of all, I'll try 95, and I'll say update. Let me see. Okay, it's coming out this way a bit. So I'll come here and I'll say minus 95, and I'll say update. Okay, that's fine. So you can now see that it has now fitted. So I'll have to now make all the beams along this line the same eccentricity to fit in with the column. Okay, so right now, if you check on this, the width of this column here is 350. So I'll have to make my beam on this area to flush with the same point with the column. So I'll come here, click on this, and then change the beam width of that, because as you can see, the columns are meant to sit directly on the beams, and with that, the column must not be bigger than the beam, but either they should be equal or the beam bigger. So right now, I will come here and make the beam width 350, and I'll say what? Update. And with that, just now, we will have to change again. Come here right now, I'll make it to, let me say 85 to flush. Let me see, and then update. Sorry, first of all, we added 50 to it, so let me use 125 and then say update. Okay, it's still coming out. Let me just do again, and then 115 update. Sorry, 105, 120, sorry, and then update. Okay, that's fine. So we have now flushed the column with the beam. So right now, I'll click on escape and then go back and change all the beams on this line to have the same properties with this. Okay, so right now, I'll now go over here and remove these other beams here, and then make sure they flush. So whenever you're doing, or whenever you're performing a raft foundation design, you must make sure you put everything into consideration. As you can see, I have put into consideration the column to beam eccentricity, and I make sure that the column and beam, they are all flushing. So also, I'll come here just now and then click on this, and then I will now come here and then click on this, and then all the way down to this place here, and then keep this here, and it will just flush automatically. Okay, that's fine. And I'll go and then click on escape, and then escape this one here, and then I will now go again to continue all the way down for the other place to insert my beams. Now I'll begin to insert the vertical beams now. So I'll come here again, this beam that does not have any form of eccentricity, which is T0. As you can see, it's here is T0, and I'll pick it up from there. What this column width is 300, sorry, 350. So I'll come here and change it to 350, and I'll come because I want it to flush with I want the beam to flush with the column. So I'll come here just now, and then I begin to insert that now. I'll come to this place now, all the way down here, and then click here and keep this. Okay. Yes, they are flushing, and I'll come again, escape, click on escape key, and then come here and then go all the way down to insert this here. If you have watched most of our course video on the design, you will not have issue on how to insert your beams. Okay, so let me just go again and then insert this. Or you can still follow the same procedure if maybe this is your first time you're watching on this. But I'll tell you that Ekidel is focused on to build your career as a civil or as a civil engineer or a structural engineer. So I would say that you don't just watch the substructure. I would say that you should go and first of all go and watch the superstructure course video so that you can be able to appreciate what we are doing for today. So okay, so I'll just begin to put my beams as you can see what I'm doing right now. So on your own, just connect all the beams together. Connect these two, and then click on this, and then go all the way down here and connect these two, and then also go all the way down, click on this, and then go all the way down here and click on this, and the beam will insert automatically, separating each of the spans as where columns are being found. And then click on this and then go all the way down here and then click this here. Okay, so we are done with these vertical ones now. We will also now return back to our horizontal one. So we'll also come here right now. We are going to change this beam width here to 350. So basically, I think we should just change all our beam width to 350 so that they can be able to so that we will not have different beam widths, just to avoid confusion during the construction. Because when you have different size of beam width or depth of beam, during the construction, it might cause confusion. So just to avoid that, you just have to use a typical beam width and beam depth for your foundation so that you will not cause confusion. Although you don't have to use different beam depth for your Raft foundation, or your beam depth must be the same, although the width can change, but the depth should remain the same. Okay, so I'll keep that just now there, and then come again just now. I've done that one. Okay, that's fine. So I'll come here now. All the beams here that we have chosen to be 300, like this one here, I'll make it to be 350 because the column itself on that line is 350 millimeter. So I'll come here, I'll come and change the width to be 350 just as the column is. I'll come here now and put this width here, change it here to 350, and I'll say okay, and then I'll come here now and then say close. Okay, that's fine. So it is now all the beams and column, they're now flushing together. And then I'll come here also, this other one. I can leave this one here because it is okay with this face here. And then this other one too is still okay. And okay, I'll leave this one here. This is just the staircase area. So right now we are done inserting our beams. Now we will now begin to insert our slab. But before then, let me just show you what we have just achieved on the 3D view. So I'll go and click on my 3D view now, and then you can now see what we have just achieved, which is the a Raft foundation. As you can see, we have done the Raft beam, which is the ground beam, and then connecting all our columns together with a beam. So right now, we'll now begin to insert our slab. How you insert your slab on your Raft foundation is that when you're doing a beam Raft foundation, the slab is meant to be at the top here, at the top of the beam, and not at the bottom of the beam. So the space between the ground floor, or between the soil and the top of this beam, or between the bottom of the beam and the top of the beam will be filled with a sharp sand or a seal, or let me say a river sand. Okay, so right now I'll just go back now and then go to my plan view here on story 00 and then go and click on my slab. Now for my slab point now, I'll now have to come here and then come to this place. On your slab depth, first of all, make it type 1, and then on the slab depth, the minimum slab depth for a raft foundation should be 200. On no account will you use 150, should be 200, and the concrete cover minimum should be 50 or 40. So I want to use 50 or 40. So whenever you are designing for any structure that has contact directly to the soil, I would say you should use your concrete cover to be 40 or 50. Okay, so depending on the kind of design code you're using, so we are using Euro code for the design of this structure. So I want to use 50 for my concrete cover. So again, we also go to the load here. Now, since you have already done the superstructure loading, as we use 1.5 for the dead load and 1.5 for the life load. So I would say you don't have to touch the load again. Leave the load as it is as of the superstructure. And then just now on this place that says relative level, here that says relative level, I'll come here just now and then to put our value here. Now I will not put this value here first. I'll first of all show you what happens if you don't put any value here. So right now, I'll just first of all insert my first slab here. Insert my first slab here. Okay. Okay, so right now, let me now show you what happens when you don't put this level, which is called relative level, on your slab when you're performing for a raft foundation. So right now, I'll just go here and then say escape, and then I'll show you the 3D view of what this slab looks like without what they call relative level. Okay, so right now, if I go here and then I'm gonna look at my slab where I put my raft slab here, you can see that this raft slab here is below and not above here. So this slab is meant to be at the top of the beam here. It's meant to flush with the beam top here and not at the bottom, because the space between this beam bottom and the top of the beam here will be filled up with either you call it a river sand or a sharp sand. Okay, so right now, to now make your slab to come upward, you have to click on the slab. When you are inserting your slab, always add what they call relative level. And how do you get your relative level? Relative level is gotten by this level here, this level you're seeing here. You get the level by using the depth of the beam, which in this case 1.7, subtract 200, which is the depth of the slab, and the cover from the depth of the beam. That gives you relative level. So in this case now, our depth of beam is 1.7, which is 1,700 millimeter, and our slab is 200. So 1,700 minus 200, that gives us 1,500. And then if we now subtract 50 from that 1,500, that gives us 1,450 millimeter. Okay, so our height of level now for this level now becomes 1,450. Okay, so I'll come here just now and then type 1,450, and then I'll click and then say update, and then you will see that your slab right now comes up automatically. Can you see that? Okay, so now you can see that your basically your slab is meant to flush with this. So if you're not seeing that flushing, I'll say you should come here and remove this concrete cover from this your calculation. So if we add that back now, that gives us 1,500, and then say what? Update. So basically right now, the formula to get this level now becomes the depth of your beam, which is in this case 1700, subtract 200 from the value, which is this 200 now becomes your depth of slab. So the depth of beam minus the depth of slab gives you relative level. So this is how they get your relative level. So if I rotate now to show you how below this looks like, you will see that this space now between this button, between this slab button, sorry, this beam button and the top and this slab button here will be filled up with a river sand or a sharp sand. Okay, so right now I'll just go around and then go and insert my all my Raft slab using the same principle. So since I've already done one, I'll just pick up this slab property and then click on the panels, and automatically the software will just insert the slabs there. So if I come here now and click on this, you will see that there will be automatically a slab here, but I always advise you don't click here. You do that on your on the plan view. So don't work on the 3D view, always work on plan view. So I'll come here now and then close this down and then go to my plan view and make the plan view 00 active, and I'll come here plan view, and then I'll come now and click on this slab to take this slab property. I think that let me see if there's two slab here. No, just one slab. So I'll undo and then make this slab property. I'll come here, click on this, right click, and then say what? Property. And then I'll just copy that property which I've already set, as you can see that. And I'll come here and I'll click on this. Now this place that says such charge, I'll say should leave it at 50,000 coefficient of a subgrade. So leave this subgrade as default. But if maybe you want to change your subgrade, I'll say that before you must change your subgrade, you have to go and read the textbook that is written by this author. I've forgotten the author, but I think I would like try to remember before the end of this part 2. Okay, so you have to go and read a textbook in foundation design written by Joseph Boyce. Yeah, correct. Joseph Boyce is a very good textbook for foundation design. So if you want to know very well, to know foundation design very well, I would say you should go and read that book, because it was from that book that this company used to program for their foundation designs. So go and read that book very well, and you'll be able to understand this software very well on foundation design. Okay, so for now, leave it as default until you have read that book. But for me, I like to leave it as default in every of my design, because the textbook tells you that this is the default value, or this is the average value for all the values on the table of the search charge. So that's why even this software use this as default. Okay, so right now I'll begin to click on my panels. So just click on your panels on all where you have your panels, and then when you're creating your panels, make sure that the area of your panel is no more than 30 meters. I think I have said that a lot on the superstructure of almost all my courses. So if you're a good follower of Ekidel, or you watch most of our videos, you must have known that the area of your panel must not be more than 30 meter square area. That is from the Euro code, and also from BS code, and also from US code, and also from British code and Indian code. Okay, so right now I want to insert my slab here now, but I'm looking at this panel is very big, so I'll have to confirm if this panel is within that rule, which I said that the area of a panel must not be more than 30 meter square area. When your panel gets bigger and it's more than that, then you begin to have issues on your slab, on your Raft foundation, because that slab will tend to punch through because of how big or large the like the area is. Okay, so right now, before I'll put my slab here, I'll first of all go and confirm that, and I'll first of all go here and then escape, or press my escape key, and then I will now come here and then just confirm that by just using, first of all, I'll check this bin length. This bin length says I can make it to use the measurement by measuring from center to center of this place. This gives me 40, let me just say 4050. And then from this to this gives me 8 point something, 8.85. So if I now multiply, if I now multiply these two values now together by using this times this, that gives me more than 30, because 8, okay, I think that should be less than 30. 8 times 4, that should give me around 24 thereabouts. So now let me just say I'm using my phone now to calculate. So I'll say 8.852, which is this one here, multiplied. So you can just try that on your own now. Multiply by 4.049. That gives me 35. Sorry, that's a very high one. That gives me 35 meters square area. So in this case now, this panel is already too big, more than the required area of 30. So right now, to now break this pan, I have to introduce a beam here to break this panel. So right now, I'll just go here on this beam, click on this, or just to be fast, I'll go and take my, I'll take on that beam and then come here and then click on this and then click on this here. So right now, if I check these two panels now, you can see that they are less than 30 meters square area. So right now, I'll come here and then say close, okay? And then I'll now come and now put my slab here. So until you have checked that your panels are less than 30 meters square area, you don't have to put your slab, else you have issues on your Raft foundation design, okay? So right now, again, I will now come here and take my slab property and then come here and put my slab here and my slab here. And then I will now click on escape here, or click on escape key. And then if I now go and check my 3D view, because we are done inserting the slab and we are done modeling this right now, I will now come here and check my 3D view here to see. You will now see that we have done all that perfectly, as you can see that. So we have done the modeling of this Raft foundation. As you can see, this is now a full Raft foundation modeling, and this is called a beam Raft foundation. If you check below, you will see that there is a void which will be filled up with a sharp sand, very well compacted, although you will learn that more on the construction stage. Okay, so right now we are done with this part 2, which is the modeling stage of your Raft foundation. Now I have said a lot, and just for a summary of what I have said, I will say that when you're modeling for or doing your design for a Raft foundation, the first thing you should consider is the width of the beam and the depth of the beam, which the width of the beam must not be smaller than the width of the column, and the depth of your beam should not be less than 1000, because 1000 is the minimum depth of beam for a Raft beam foundation. And then for your slab, when you're inserting your slab, always add what they call relative level, so that the slab can come upward and not below. And to do that, to get the value of your level for the slab of your slab, you have to subtract the depth of beam minus the depth of the slab, which in this case we did 700 minus 200. That gives us 1500. Okay. Then also I've also told you that when you're performing, before you insert your slab on any of the panel on your Raft foundation, you must check that the area of a panel, which is this now, is not a panel, this is a panel, this is a panel. So you must check that the area of a panel is less than or equal to 30 meter square area, because in this case, as you can see, for this area, this place here was bigger. This panel here was just a one panel and was bigger than 30 meter square area, which was giving us 35 point something, 35.84. And then because it is more than 30 square area, we have to now introduce a beam. Okay, so and then insert our slab. So this is the summary of when you're modeling for your Raft foundation. So once you follow all these guiding principles, you will not have issues in your Raft foundation design, which you are going into on the part 3, which is the Raft foundation design. Okay, so right now we will now watch out for the next, which is now the part 3. So thank you for being with us to this very time, and then you will now see how the load is going to affect the weight of this structure is going to affect the depth of, or is going to affect the beam and the slab of this foundation. Okay, so thank you so much, and then God bless you, and then watch out for the next. Bye.